Hello, I wanted to share a signal generator design that I made. The main goal of this generator is to drive pretty high current loads at low frequencies at 50% duty cycle, because that's what I need for a project of mine. It is based on a CMOS 555 timer IC in 50% duty cycle configuration. This one is from a failed attempt. I call it cubic signal generator because in my head 50% duty cycle makes it look even more square. Well, anyway, initially I wanted it to go up to 1 megahertz. That's why I chose CMOS version, but I made a mistake in the design and it goes only up to 100 kilohertz or so. I should have used totem pole FET configuration to amplify the signal. In the configuration I have, there is just this p-channel MOSFET that amplifies the signal, and it feeds charge into this output line, and the charge has nowhere to go but this resistor and the connected load. A bit of a fail, I know, but I learned a lot. After all, learning the things is the reason why I decided to make one instead of buying it. As I said, max frequency is limited by the FET, and it's somewhere in 100 kilohertz range. At high frequencies it turns into 60% duty cycle, and higher than that, and it really stops being a square signal anyway. I'll show you on the oscilloscope. Here are the ranges for each dream pod. Initially I wanted it to go into higher frequencies, and that's why I made different dream pods to fine adjust, but it's pretty useless at this moment. I call it low fidelity square cubic signal because, well, it stops being 50%. And no, it doesn't actually produce low 5 beats to study to at 150 kilohertz, unless you're a bat or Morbius. It is powered by USB-C, as you can clearly see. No power delivery circuitry here, just good old 5 volts, and it means it can power stuff with up to 2 amps. Limited by these poor man's short circuit protection resistors, of course. Let's hook it up and see it in action. And let's hook up the oscilloscope. Grounds first. I am using digital oscilloscope, and yeah, here's the output signal. As you can see, it is currently set for the lowest frequency, around 5 Hertz. Oh, my power bank stops supplying current when there is no load connected, and it's basically open circuit, so I'll have to restart it quite a few times. And the left input is set for the highest frequency. Let's zoom in. And as you can see, it is plus or minus 150 kilohertz, but of course it is at 60% duty cycle. It is quite finicky, and it is really difficult to fine adjust, but it's good enough for purposes of mine. Let's zoom in and see the rising edge, and it's pretty clean, as you can see. 100 nanoseconds, not the fastest rise time, but pretty good. And the main culprit is, of course, the falling edge, because of that p-channel MOSFET, and it's so dirty. I want to wash my eyes after seeing that falling edge. But yeah, it's still good enough for the purposes of mine. That's basically it. I will share a link in the description with the schematics and PCB designing keycard, along with some other stuff. Thank you for watching. If you have some ideas or criticism, I will welcome that, because I have a lot to learn in electronics. So yeah, bye.